Hi guys, welcome back. Today in this tutorial we are going to learn about the random static address, and this is a type of device address that we have seen in the previous tutorials. We have learned how the advertisement packets are formed and what are the address types. If you haven't seen my previous tutorial, just watch the previous tutorial. The link is just up on the corner of this video. And now let's start our random static address. The first thing in a random static address is it's a randomly generated value, and we can just set any random address of our choice. It will not change unless we use our program to generate the address randomly. It will remain the same for the power cycle. So we have some rules according to the BLE specifications, the core specifications. We have some rules and regulations. We have to follow these rules when we are making this 48 bits or 6 bytes of address. And some beginners who don't know about octets are basically 1 byte. So in BLE specification you will see this a lot. They will say octet instead of bytes. So if you are a new engineer or a programmer, you might hear this for the first time, then it's not a big deal, it's just a simple byte. So we have to follow certain conditions as mentioned in BLE specifications. The first one is the highest first 2 bits must be 1 for generating a random static value. Here is the least significant bit, and here is the most significant bit. So here the most significant bit on this type, so the first condition is the most significant should be 1 and 1. The first or the highest bits should be 1 and 1. The second condition is the rest of the bits, all bits, cannot be 0 or cannot be all 1. Okay, so they shouldn't be like 0 0 0 0 0 up till 48 bits, or they cannot all be 1 1 1 1 1 up till all the 48 bits or 46 remaining bits, because the first 2 bits are 1 and 1. This is the second condition that we have to follow. And the third rule is the device address will not change during a power cycle. So in the SDK this has been implemented. So if we try to change the device address during the power cycle, or the device hasn't been reset, then our address, the handle, will become invalid because it cannot change. So here we have seen the most significant bit should be 1 and 1, and here the other bits you can put any address or any random value which is up to 48 bits, and then we can see we can adjust this address as we want to. So we can write any value in this random side. So previously we have seen the 3 steps. So here we need to see in those steps we have some configurations for setting the random static address. In order to write the program for random static address, we need to understand this structure. We will see it in the next slide. This BLE gap address type is the address type structure is a structure which will hold the values for the type of address, and we will initialize it. The second step would be initialization. First we will create a variable of this type, then we will initialize it, assign it the value, and then in the end the last step would be we will call this function which is set BLE gap address. We will call this function to set the address of our device. So here I put a small note as well for some people who want to get more information about these devices. The nRF devices basically have some special registers, and in these registers we have some randomly stored values, and the soft device will automatically assign these random static addresses if we don't program our device. In that case, the soft device will automatically calculate and follow the rules, and it will create a random value and it will assign it to the device. But if we want to see these registers, there are two registers. The first register is device address type, is the first register, and this address type register is a 32-bit register, as our processor is 32-bit, so all the registers are mostly 32-bit. So the remaining 31 bits are of no use. Only the first bit is the bit that will set the value. For example, if the bit 0, the first bit, the bit 0, if it's defined or it's set to 1, then it means our address is a random static address. So if we set it to a public address value, then we have to set it to 0. But soft device will do it internally, so you don't need to worry about this too much. Devices also have another two registers, which are device address register 0 and register 1. These two registers together, they hold 64 bits, but we are just concerned with the 48-bit value, which is actually the 48-bit address. So how it's assigned, the address 0 register will have the first 32 bits of the address, and the device address register 1 has the most significant bits, which are at position 0 to 15 bits of the device. So this was some extra information in our coding. We didn't set the address in the base code that we previously did. We did not assign any address to the device. Then how come our device has the address? It was because of these registers. There was a random value that was saved in these registers, and the soft device will automatically assign this to our device. But today we are seeing this random static address, and we will program this. So we have seen the steps and we know all the details, how it was happening before, and now how we are going to program it. But first we need to understand the structure. So let's move to the next slide. So this is the BLE gap address structure, address type structure, and I have a picture of this. So the first thing here is the address ID peer, and here, as you can see, it's only valid for peer addresses. This bit is set by soft device, and we will see that in future tutorials. By the way, we should also know that least LSB format means the address we are write in the form of array will start from LSB to MSB. So for example, if we are writing the address in array, for example 0x1 2 then 0x4 2 then 0x4 4. So this one is the address that we are writing is from LSB to MSB. So this would be the MSB. So we have to make sure the MSB should have the highest two values that should be 1, otherwise this address won't work. So address type will be set using the SDK's preset constants. So we can use this structure to set and get the addresses of device. So the main things that are here is the address type, and this address type will be set according to the preset constants, or the SDK has the constants for us, and we will use those constants. The last thing which is important is the unsigned int 8 type address and its length. So length is, as you know, it's 6 bytes, and the address would be this. So we have to define this type of structure variable, and that variable then we will pass the address to that variable, and then we will call the set address function to set the address. And if we want to retrieve the address of the device, then we can use the get address function to get it. In order to get the address, we have two basic steps. First, we need to define a variable of type BLE gap address type T. BLE gap address T. We will define a variable of this type, and then the next thing we need to do is we have to call a function to get the address and save it into the structure, which is this type. Address will be saved into this, and we can retrieve the address from this structure. So here are some useful functions that we will be using in our programming. So before going into the programming, I wanted to show you these functions which are really important, and there are some special cases in which we use different types of functions. So let's see. The first function is unsigned 32-bit unsigned 32T, which is the return value SDBLE gap address set. So this function will set the device address. Once set, the device address cannot be changed. This should be kept in mind, and if we try to set it again, if using this function, the address will be invalid. So we have to be careful about this. We have to make sure we set the address in the power cycle only once. Then the next function is the BLE gap address, and we have already seen we have two steps. First, we have to define BLE gap address T variable, and then we will call this BLE as SDBLE gap address get function to retrieve the address, and this address will be saved to that structure type variable, and then we can use it in our program. The last one is the special type of a function, and we will also be using this one as well. This is SDBLE gap advertisement address get. Basically, we get this address from the advertisement packet, or the PDU, which is protocol data unit. So from there we retrieve this. So this function is used to get from the PDU, and it's useful in some cases. We should also know that in case of unresolvable private address, the address might not be the same as the current address, as the device will update its address periodically. So for example, we retrieve the address of the device. Maybe the address of the device is not the same anymore because of the timeout value. The device's address changes after some timeout value. If we want to see the address of our device from the PDU, so we can check the device address with the help of this function. By the way, in this function we have one extra thing other than the pointer, which is advertisement handle, and this is the advertisement handle. So we also have to pass the advertisement handle of the device in order to get its address from the PDU. So we have to make sure we know everything, and these are the basics for random static address. And now we are going to start the programming. Okay guys, now we are going to take a look at how we can program this random static address. So first of all, we will go to this PC and go into the C drive. Here we have our nRF SDK. Open the examples, and here in my projects, if we go here is the base app project, and if we right click here, we have already created this project in the previous tutorials, and if you haven't watched my previous tutorials, you can watch it, because we will be using this base project as a base project code as our future tutorials base code. So this will be very important, so make sure you watch my previous tutorials as well. Now I'm just going to copy and paste it here, and it will create a copy of this project, and let's say it's going to be our project 3, and its name would be advertisement and a random static address. So I will open this, If you are using nRF52832, you should open this one, and if you are using nRF52840, open this one. So I'm using nRF52840, so I will open PCA10056. Our soft device for this is S140. For nRF52832, it's S132. So I will open this, and here is the Sagar Embedded Studio folder, and open the EM project file. This will open our code along with all the project, and this was the basic code that we wrote in the previous tutorials. Now today we are going to learn about the static setting the static advertisement address, so a random static address for the advertisement. So now we need to create a function which will be called to set the random static address. So for that, let's create the new functions here just above the main function. So the first function would be and in this function we need to call a function which would need error code. For that we will create an error code variable. The next thing we need to do is we have to create a BLE gap address type variable. So for this it needs to be static, so we will create this BLE, and let's name it as a RS address, random static address. And now we have to assign the values for the random static address. So for this, let's assign the values to the address. It's a 6-byte address, so for that I will write rs address dot addr, which is address of 0, and let's assign it 0x00. Then we will copy this 5 times more to make it 6 bytes. 1, 2. So we have this 6-byte address. Make sure the most significant bit has all the bits, or at least the most significant bits should be 1 and 1. And for others, let's give them some random values like. So we have given these address values. This would be our random static address, and now we have to set the type of the address as mentioned in the structure. So for that, so here the structure address type, and for this we will use the constant BLE gap address type, and here we will select the random static address, and it's finished. And now we have to call the function which is stBLEGap address set, and for this we will just pass the pointer to this structure. So I'm just passing the address of this structure, so for that I will use and now we have to see if the device has successfully set the address or not. So for that we will use the error code to check if the value was successfully set as our address or not. So if it wasn't successful, then it's going to print a message in the log which would be, and that would be to set the address. And if we want to read the address, for this we have to create another function. So let's say, and the new function would be, so for this let's create the function, and we will do the same procedure here. Error code variable will be created here, so we can use this in case of an error. And now we have to create a static type BLE gap address structure variable. So this would be, let's say, my device address. And now we need to read the address, so for that we will use a function gap address get, and here we have to pass this pointer to this variable, so we are just passing its address. And if the device has successfully read the if the device successfully get the address, then we will read it. For this, let's print out some message, and here we have to see the value in hexadecimal. In order to see the values in hexadecimal, we will use percentage, and the number of hexadecimal values should be 2 and then x, and it will show us the hexadecimal value. And let's read it. So my device and let's print one more message. In order to print hexadecimal values of the address, we have to follow the same pattern, and we are just making a special format so that we can see the address together in a special format. So for that, we are just putting the percentage 0 to x for each 2 hexadecimal values, which would be 1 byte. So we have 6 bytes here. Let's read the values. So for that, let's put it here. And the last comma should not be there, and we will close this. And this is just one line. If I wrote it in one line, it would be so long, so I just added some spaces. So I don't want to make it a long line, so I just pressed enter on each comma. So it's completely okay for this, because in the end we are using the semicolon, so the instruction will be finished until this point. So it's finished, and now we will just call these functions in our main code to see the results. So before we start advertising, we will set the random static address. So for that, let's call the function set random static address, which we just wrote above. And after advertising, once the advertising starts, let's read the address. So get random static address, and that's it. And now we will press Ctrl+S to save, and let's build it to see if there is a mistake or not. Okay, once the code is compiled, make sure your device is connected. Now I will be using nRF5 to 840, so I already selected this PC of 10056. So I'm just gonna click on the connect, make sure, and don't confuse about the Bluetooth programming. It's similar for both of the devices, so you don't need to worry about the code. So just click on the target, connect, and erase all. So this will erase the device's memory, and then download. And once it's downloaded the code into the device, we will open the terminal. We can open the MobiX terminal. If you have this, you can open that, or we can also use PuTTY terminal. I'm just gonna open the MobiX terminal, and to open terminal, serial terminal, I would select 115200 baud rate, and I will select this CH340 COM10. I will open this one, and I will reset my device so that we can see all the message. So here it's showing that the device is fast advertising, and The address type is 01. So 00 would be the public and 01 is the random static, and this is the device address that we set in the code. As you have seen, it's the same as the device address that we set in the code. And if we open the application in our mobile phone, if we open the NRF Connect in our mobile phone, then we can also see here my device is SamBT, and here the device's address is FF33662398CE, and we can see it here as well. So this is the device address. Now the next thing we need to do is we have to see the packets. Make sure your dongle is connected. I will minimize this and I will open the Wireshark. And if you don't know how we configured our Wireshark, then you watch my previous tutorial on Wireshark, how to configure it for nRF packet sniffer. Now I'm just gonna open this, double click on this, and I will start receiving some packets. So here there are so many packets, and if I apply the filter, which is BTLE and dot advertising address, and we see all of these advertising addresses, and here we can see our address as well. So this one is our device's address because we set it ourselves. So now we can check this. So this one is the broadcast or the advertisement, and let's see a device's address. So if we take a look here, this is the advertising address that's being sent in the packets of BLE, and we can see that our address is CE98236633FF, which we set, and now we can see that our device is advertising with this address. This was the random static address. If we click on this, we can see the address, and we can see our packets header, and in the packet header we have we can see the TX address is random static address. So this also shows that our address is random static address, so we can see in the BLE packets as well. That's it for today. I hope so you have learned something new today. You know how to set the random static address, how to get the random static address, and there is one more thing left, but that's how we get the address from this PDU. We will check this in the next tutorial, and please be sure to support me on PayPal and Patreon. If you have any questions, you can ask me in the comments below, and if you are new to my channel, please be sure to subscribe to my channel. Please share my video among your friends. Thank you very much for watching. See you in the next video.